Hello children, today we will revise ionization enthalpy. It is also known as ionization potential. In the previous video, I told you all briefly how development of periodic table took place, and after that atomic size and the trends of atomic size. Okay, let us start ionization enthalpy today. Ionization enthalpy, as I have already told you all, it is the amount of energy which required to release an electron from isolated gaseous atom. Right now, for example, if you want to release electron from sodium atom, electronic configuration of sodium is 281. Okay, why there is a need to, the question is that why there is a need to remove electron from the outermost shell? Answer is to become stable, to achieve the stable electronic configuration of nearest noble gas. Okay, so this process of removing electron is required to release electrons so that it can achieve the stable electronic configuration of nearest noble gas. Right? So one electron is present in the outermost shell of sodium. If you will remove this one electron, it will become stable by achieving the electronic configuration of nearest noble gas. Right? So whatever energy is required here to remove the electron from the outermost shell of sodium is known as ionization enthalpy. Ionization enthalpy. Now question is, why energy is required to remove the electron? Because electrons are held with nucleus with electrostatic force of attraction. There is a electrostatic force of attraction between electron and outermost shell. Electrostatic force of attraction between nucleus and outermost shell. So this electrostatic force of attraction hold the electron. Electrostatic force of attraction of nucleus hold the electron. So to remove the electron from the grip of nucleus, we have to supply energy so that this force of attraction can be overcome. Right now, that's why energy is required to release the electron. Okay, this energy is known as ionization enthalpy. I hope you people understood. Okay, one more term is successive ionization enthalpy. Successive ionization enthalpy. The term succession means in a sequence. If you want to remove electron in a sequence, for example, after removing first electron in the outermost shell, second you want to remove. Okay. Third you want to remove. So whatever energy will be required in the sequence, that will be called as successive ionization enthalpy. To remove first electron, IE1 is required. To remove second electron, ionization enthalpy 2 is required. To remove third one, ionization enthalpy 3 is required. This is called as successive ionization enthalpy. Successive ionization enthalpy. Always remember, when we talk about successive ionization enthalpy, there is a comparison between them, right? Ionization third is always greater than ionization enthalpy 2 is always greater than ionization enthalpy 1, right? Always remember, this is the trend of ionization enthalpy 1, 2, 3. Okay, so 3 is greater than second and second is greater than first. Reason already I told you all, right? So question may come in exam. Okay, arrange the following in the increasing order. Okay, arrange the following, or question may come, which among the following is correct? Which among the following is correct? For example, lithium, sodium. Lithium is greater than sodium. Sodium is greater than potassium. Right? Ionization enthalpy trend I am talking about. First option. Second option will be given. Potassium is greater than sodium. Is greater than lithium. Third will be A and B both. Fourth one be none of these. None of the above. You have to choose the correct one. Okay. We all know trend of ionization enthalpy. when we move left to right in a period, ionization enthalpy increases. Why ionization enthalpy increases? Because we all know ionization enthalpy is dependent on nuclear charge and atomic radius. Nuclear charge and atomic radius. Higher the nuclear charge, higher will be ionization enthalpy. Lower the size of an atom, higher will be the ionization enthalpy. Because when size will be small, the distance between nucleus and outermost shell will be less. It means the force of attraction generated by the nucleus over the electron will be strong due to the less distance between the outermost shell and nucleus. So here electron will be held strongly. While electron will be held strongly, then more amount of energy will be required to release the electron from the outermost shell. Okay. Similarly, when the nuclear charge will increase, nuclear charge means number of proton present in the nucleus. When more proton will be present in the nucleus, it will attract the electron more strongly. So energy will be required more. That's why ionization enthalpy increases when we move left to right in a period. Similarly, if we talk about top to bottom in a group, when we move top to bottom in a group, atomic size R increases. Atomic size R increases. Nuclear charge NC also increases. Number of cell also increases. I have already told you all, when we talk about top to bottom in a group, number of cell always dominate over nuclear charge. So here increment in the number of cell will dominate over nuclear charge. It means the force of attraction generated by the nucleus toward the electron will be less due to the shielding effect, as I have told you all day before yesterday. Clear na? So when there will be less attraction between the nucleus and electron, the force of attraction between electron and nucleus will be less. So here less amount of energy will be required to release the electron. Easily you can remove the electron because the grip of nucleus over electron will be weak. Right? So ionization enthalpy decreases when we move top to bottom in a group. Right? I hope you understood. So this particular question is dependent on trend of ionization enthalpy in a group. When we move top to bottom, ionization enthalpy decreases. So you can see here lithium at the top, then after sodium in a group, then potassium. It means lithium's ionization enthalpy will be high, then after sodium, then potassium. So correct option is first. Right? Now come at electron affinity. I'm a little bit fast because already we have done this topic. Electron affinity. It is just opposite of ionization enthalpy. In case of ionization enthalpy, I told you all the amount of energy required to release the electron from the outermost shell of a isolated gaseous atom. But suppose you want to add electron in the outermost shell of an atom. Okay, so while you are adding electron in the outermost shell of an atom, amount of energy releases. So whatever amount of energy releases while you adding electron in the outermost shell, okay, that will be called as electron affinity. So you can define it as the amount of energy releases when an extra electron is added in the outermost shell of an isolated gaseous atom, known as electron affinity. Question is, why there is a need to add electron in the outermost shell of an atom? Again, answer will be to achieve stability, to achieve the stable electronic configuration of nearest noble gas. Let us consider the example of chlorine. Atomic number 17, electronic configuration is 287. From the electronic configuration of chlorine, it is clear that to become stable, chlorine needs one electron. So how chlorine can get electron? It gains electron, or electron is added in the outermost shell of chlorine. So when you will add electron in the outermost shell of chlorine, some amount of energy will release due to the electrostatic force of repulsion between the electron present in the outermost shell and upcoming electron. Here 7 electrons are present, so upcoming electron will feel repulsion, right? So to overcome this repulsion, some amount of energy, so not to overcome, here due to the repulsion some amount of energy will release. This is called as electron affinity. Okay, whatever I am telling to overcome term will come in case of electron affinity 2, means I am talking about successive electron affinity. So always remember, electron affinity is an exergonic process. It is an exergonic process. While if you talk about successive electron affinity, means in a sequence if you want to add electron, successive electron affinity is always an endergonic process. Why it is an endergonic process? Because while electron is coming in a succession, more repulsion will be caused by these electrons present in the outermost shell. So to overcome this repulsion, some amount of energy we have to supply, right? So that is called as successive electron affinity. Clear? If we talk about trend of electron affinity, when we move left to right in a period, electron affinity increases. Why electron affinity increases? Always remember, electron affinity is dependent on nuclear charge and atomic size R. When we move left to right, nuclear charge increases along with decrement in the atomic size. So when size will be small, the force of attraction generated by nucleus for electron will be more. It means upcoming electron will feel more attraction. So easily electron can be added. That's why electron affinity increases when we move left to right. Similarly, if we talk about nuclear charge, when nuclear charge will increase over the nucleus, it means electrostatic force of attraction caused by the nucleus for electron will increase. So when electrostatic force of attraction of a nucleus will increase, easily electron can be added into the outermost shell of an atom. That's why electron affinity increases when we move left to right in a period, right? Similarly, if we talk about top to bottom in a group, while we move top to bottom in a group, electron affinity EA decreases. Electron affinity here will be dependent on nuclear charge, atomic size R and number of cell N. So when we move top to bottom, nuclear charge increases, atomic size increases and number of cell increases. But here number of cell will dominate over this nuclear charge. Number of cell will dominate over the nuclear charge. When R will increase, it means distance between the nucleus and outermost cell will increase. It means upcoming electron will feel less attraction. So it will be very difficult to add the electron into the outermost cell. Right now? That's why electron affinity decreases when we move top to bottom. Here nuclear charge is also increases, but don't be confused. Many times I told you all, nuclear charge when we move top to bottom increases along with number of cell. Here number of cell will dominate over the nuclear charge. Clear na? It means number of cell will behave as a curtain. So less attraction will be felt by the electron present into the upcoming electron which is coming into the outermost cell. Right? So this is the trend of electron affinity. Clear? Some example we can see. Choose the correct trend. Option will be given to you. Chlorine greater than fluorine greater than bromine. Then after second, fluorine is greater than chlorine is greater than bromine. Third, A and B both. Fourth, None of these. You have to choose the correct option. Trend of electron affinity, you have to choose the correct option. Chlorine is greater than fluorine, fluorine is greater than bromine. Means we are talking about halogen family. Let's see the position of different halogens into the group number 17. Fluorine, chlorine, bromine, iodine, astatine. Right? So, top to bottom ionization enthalpy, electron affinity decreases. It means first fluorine. Electron affinity of fluorine is greater than chlorine, is greater than bromine. No, it is wrong trend. By the time I told you all, if you talk about trend of electron affinity in the halogen family, chlorine is at top, then after fluorine, then bromine, then iodine, then astatine. It means correct trend will be fluorine is greater than bromine. Reason behind is the presence of 2p and 3p orbital. I think there is no need to explain in detail. Many time I told you all. Okay. The reason behind is the presence of 2p orbital in fluorine and 3p orbital in chlorine. Right? One more, we can discuss electronegativity. Electronegativity EN. What is electronegativity? Electronegativity means the tendency of an atom to attract the shared paired electron. The tendency of an atom to attract the shared paired electron present in a covalently bonded molecule. For example, HCl. It is a covalently bonded molecule. Right? Here shared paired electron is present at the center. But due to strong electronegativity or high electronegativity of chlorine attracts the shared paired electron toward itself. This ability of chlorine to attract the shared paired electron toward itself is called as electronegativity. So electronegativity is tendency of an atom to attract the shared paired electron toward itself in a covalently bonded molecule. Right? If we talk about trend of electronegativity, when we move top to bottom in a group, electronegativity decreases. Why electronegativity decreases? Because R increases and number of cell increases. Okay? Many times I told you all, nuclear charge is also increases here, but there will be no effect of nuclear charge because it will be dominated by the number of cell. Clear? So when R will increase, the distance between the nucleus and outermost cell electron will increase. It means less force of attraction will be in between the electron and nucleus. That's why electronegativity decreases. Right now, when nucleus will be away from the electron, it means attraction of electron and the nucleus will be less. So when easily electron cannot be attracted by the nucleus, automatically electronegativity will decrease. Right? Similarly, when we move from left to right in a period, electronegativity increases. Why it increases? Because R decreases and nuclear charge increases. When R will decrease, it means distance between the nucleus and electron will decrease. It means the force of attraction caused by the nucleus will be strong. So electron will be easily attracted toward the atom. Similarly, when nuclear charge will increase, means charge over nucleus will increase. Plus charge. So when plus charge will increase, it will attract the electron easily. That's why electronegativity increases when we move left to right in a period. Right? This is the trend of electronegativity. Example I have given you all.